Everyone, welcome to my channel. So in this video there are two goals. The first goal is to see, of course, solve this problem, and then we are going to do some left coding here. And the second goal is to see how it should behave in a real coding interview. So I'm going to go through the process during the time I do the coding. So in general, the first step is always try to understand the problem in a real coding interview. If there is anything unclear, bring the question to the interviewer, and also at the same time think about some edge cases. So let's read through this problem. So given the head of a linked list, return the list after sorting it in as any other. So the follow-up is, can you sort the linked list in O and log in time and O1 regarding the memory? So constant space, okay. So for example, for this one, after we sort it, it's going to 1, 2, 3, 4. So if it is empty, then we return empty. So let's see. It says the number of the nodes in the list is anywhere between 0 to 50k, and also the value is between minus 100k to 100k. Alright, so I think it's very clear for the question. The only edge case I can think about is, what if the list is empty? So if it is empty, if it is non-pointer, then we just return non-pointer. Otherwise, I think we should be good to go with the general algorithm. So the general algorithm, actually, it is a merge sort. Okay, so the next part is about finding a solution. The solution is pretty straightforward, which is doing some merge sort. So usually do merge sort, you have two ways. Whether you go top down using recursion, or you go bottom up for using the iterative way. So if the follow-up question is about using O1 memory, so it is mostly about asking us to do the merge sort in an iterative way from bottom up. But actually, I don't really want to do that because that's very tedious for us to do. But in case you're interested, please try on your side to do the iterative, to do it in an iterative way, which is guaranteed to have like the O1 regarding the memory. But let's say we are just going to use the merge sort top down using the recursive way. So the runtime is going to unlock in, and regarding the space wise, it really depends on the stack, the recursion stack. So let's say if we are using recursion, what is okay, so it could be anywhere. Okay, so the runtime is going to be unlocked in for sure, and the space is going to be logged in if we use the recursion to implement the merge sort. So the next step is for us to do some coding work. So for coding, please care about the correctness, and also the readability, and also don't be too slow. So let's start to do some coding work. So first of all, so this is a recursive function. So if we will define the recursion accent. So if the head is equal to a non-pointer, or the head.next is equal to a non-pointer, then you're just going to return the head itself. Otherwise, it is the general logic about the recursion. So we are going to try to find the middle point. So how to find the middle point? We are going to use the two pointers, the fast pointer and the slow pointer. So this is, let's call it the fast pointer. It's equal to head, and also we have a slow pointer, which is equal to head as well. So every time we move the fast pointer twice, and we move the slow pointer once. And when fast pointer is pointing to some non-pointer, then of course the slow pointer is pointing to the middle. So we would say, well, fast is now equal to non-pointer. So we are going to have slow is equal to slow dot. Well, let's see. So let's say we are going to, if we are going to move fast pointer, so fast is equal to fast dot next. If fast next is equal to a num pointer, then we are just simply going to break. And then fast is equal to fast dot next. So fast is if fast is equal to num pointer, then we are going to break. And then fast is equal to fast dot next. Okay. And then we are going to have slow is equal to slow dot next. And at the end, slow pointer should be in the middle. What we need to do is we need to have the mate pointer. Let's say we have defined the mate pointer, which is pointing to slow. So the thing I'm thinking about currently, so let's say there are two nodes. Fast, let's say fast move twice and then slow move once. Then the mate actually is, well, the mate actually is slow dot next. So which is the next half. And we also should set slow dot next is equal to num pointer. And then we are going to sort the head, and then it is going to return the left sorted part, and the other thing I'm going to have sort the right part is equal to sort list, which is made. And then finally we are going to do a merge. So we return merge head and the mate. Alright, so I think currently that's mostly it. So we need to implement the helper function, which is merge. So merge is going to merge two sorted lists together. We have, let's say, left node the left and the left list node the right. So we are going to say, okay, list node is equal to, let's have a new head, list node. Well, it is, well, left is not equal to a num pointer and right is not equal to a num pointer. So we are doing the comparison here. We are going to say, alright, so if the left dot value is smaller than right dot value, then we are going to have head, so list node, let's set, well, I would say head is equal to new list node, head dot next is equal to new list node, which is left dot value. And then we are otherwise head dot next is equal to new list node right dot value. And then head is equal to head dot next. And then after that, either right or left or right is going to be none. Okay, so we need to actually move the left is equal to left dot next. And here it is right is equal to right dot next. So here we need to say if head dot well, we actually need to have the list. No, so we actually need to have the node, which is the iterator. So iter, let's say it has a head, because if we move the head here, it is going to cause some issue. So iter dot next. So finally we need to return head dot next. So that's why I mean that if we move the head, then we are going to encounter some issue. So here we need to say if left is not equal to a num pointer, then we are going to have head iter dot next is equal to left. Otherwise, if it is the right that is not none, we have the iter dot next is equal to right. So that's mostly about the merge part. So let's see. I think it mostly looks good. So please don't forget to do some testing. So for testing, for the easiness of this video, we are just going to rely on this platform to help us debug. Okay, so some runtime arrow, sort list. Well, let's see why. It says it is overflowing. So we have the head. If head is equal to none or head.next is equal to none, then we are going to return head. Otherwise, we need to have the fast pointer and the slow pointer, and then we. Oh, actually, we should merge the left and the right. So that's the thing. Let's do another run for here. It's another stack overflow. So it seems like we have something wrong with this recursive function. So if head is equal to none, head.next is equal to none, which means if it's not 0 or 1 node, then we are going to return the head. Otherwise, we have the fast pointer and slow pointer. So while fast is not equal to none, so first we move to the next. If fast is equal to none, then we are going to break it. Otherwise, we are going to move the fast again and then slow to the next. Sure, I think it's fine. So let's say there are two things. There are two nodes. So first of all, we move the fast to the next, which is the second node. So the second node is not none, so then we move to the last node. So last node is going to be a none pointer. And then we just move the slow for once, okay? And the mate pointer is actually the slow.next, okay? And slow.next, let's set as none. And then you're going to sort the head and sort the made, the left half and the right half, and then you're going to do merge. Well, so it doesn't seem to be incorrect, but let's see the merge. So if you call the merge, we have the left and we have the right. Head is equal to the list node and then iter pointing to the head. So if the left is not a non-pointer or right is not equal to a non-pointer, then we do the comparison. So the next is equal to the list node. Okay, so we have the next node as has a value as the left value. Otherwise, we have it at the right value. So, and we set the iter is equal to iter.next. I think until now I don't see any obvious issue here. Let's say if the left is not equal to none, then okay. If right is not equal to none, then iter is equal to iter dot. Well, say if iter is equal to iter dot next. Well, I still don't think that's the thing. So finally we return head dot next. Let's see why it is not really working. So let's print out something here. So maybe let's print out yeah, so usually in a coding interview, if you get some bug here, you can go through it, or you can just run through it by adding some debugging input. So let's say we have the head value and this is the made dot value. So let's see why it is. So it's 4 and then it's 3. So first of all, it is 4, and then it is the made is 3. So what is the input actually? So the input is 4, 2, 1, 3. Why the made is 3? I think the made should be 1 here. So let's say we have 4, 2, 1, 3. Yeah, so it is 4, 2, 1, and 3. So fast pointer is here and slow pointer is here. So first of all, we move the fast pointer twice and slow pointer once. Oh, I see. So I think I quite understand. Yeah, I think I quite understand why. So while fast is now equal to none, fast is okay, so I think I quite understand here. So because we are trying to move this one and then we try to move this one to here, that's essentially why it is not really working here. So if a fast is now equal to a non-pointer, fast is equal to the next. Let's say fast dot next is not equal to fast is equal to fast dot next. And then if fast dot is equal to a non-pointer, then we are going to just break here. So in this case, let's say first of all we move twice and then we move once here, and then we should have, and then we move during the time we move the fast pointer. So the first one and the second one, it is already out of the range. So if it is already out of the range, then we just don't move it. So now I think we should have, yeah, I think now we should be able to do that. So that's because we just move the fast pointer. Yeah, so essentially it's something like we have some issue when moving the fast and the slow pointer here. But after we solve this issue, I think it should be good. Okay, so I think we should be good regarding this piece of code. So that's pretty much about the solution to this question. If you have any question regarding the solution or regarding whatever, feel free to leave some comments below. So if you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.